Hello friends, welcome to GreedyPie. I am Arham Doshi and let's get started. So this would be the last video of the sorting series, and after this in next week we'll be starting with searching, and in that we'll be focusing about binary search. Okay, so let's see what the two pointer is. Two pointer is basically an optimization technique that can be used to reduce the time complexity of many problems that can come in CP and in DSA. So let us look at one such problem. You have been given an array and you have to find the sub array with the sum equal to x. And for example, the array is like this, and we have to find whether any sub array has sum equal to x. So what's the most brute force approach is, we can go through all the subarray. Like, this is the starting point of the subarray, this is the ending point of the subarray, and we will find the sum of that subarray that is from I to j, and if that sum is equal to x, we can like return that particular subarray. Okay, and this we can find the sum of subarray in like of n complexity. We can just run one more loop. We can like keep a variable sum, and we can run one more loop, that is, let's say k, and it will go from I to j, and it will increment sum by the elements of array, and if that sum is equal to x, we can return it. And this is the most brute force way. So the complexity of this method is of n cube, because we are using 3 loops. Okay, so can we optimize it further? Yes. So one thing you might notice is, if we expand the subarray, let's say our subarray is from index 0 to 4, and if we expand this to this subarray from 0 to 5, we need to add only one element to that subarray. Okay, so in this case, the sum of all these elements are like 1 plus 3 plus 2, that is 6, plus 5, that is 11, and the sum of this is 12. So we need to just include one more element here. Okay, so what can we do here is, we can maintain the sum variable, and we can just simulate this, and we can just start with this, and for getting new subarray, we can just add one more index to this. So we can just add one more element to this, and that will already give us new subarray. Okay, so now after each iteration of I, the sum will represent the sum of subarray from I to j. Okay, and this method will give us the complexity of n square, because we are using 2 loops. Okay, so to optimize it even further, we need to use a technique called two pointer. Okay, so in two pointer, what we do is, we basically maintain two pointers L and R, and let's n will skip the we will maintain the sum of elements between L and R, and and this is basically a window, and we will try to maintain these two variables such that the sum is always less than or equal to x. We will never let the sum grow bigger than x. Okay, so what we do is, we can like at initially we can start both L and R with the first element, and we can maintain their sum. So here the sum is equal to 1. Okay, we will expand this window until we cannot expand it even further, which means if we try to expand it even further, then the sum will exceed x. So let us first try to see this. if we try to expand it like this, the sum is 1 plus 3, that is 4. So in this case we can expand it. We will try to expand it even further. In this case the sum is 1 plus 3 plus 2, that is 6. So this case also we are expanding it. Now if we try to include 5 in this, the sum would be 11 and that would be greater than 8, and we cannot do this. Okay, so we will stop expanding here. Okay, and whenever we stop expanding, we will see what the sum is, and if the sum is like equal to x, then we can just return that. Otherwise we will be checking other windows. Okay, so what if we have expanded maximum? After we have expanded maximum, we will to expand maximum, what we are doing was we are just moving the right pointer to the right side until we cannot move it more right. After that we have reached to the maximum right, and if we cannot if the sum is like still less than x, we can just move the left pointer by one position. Okay, so now we will try to start both L and R from here, and we will again try to go as right as possible. So sum of these two are like 3. If we try to expand it, sum is like 5. So if we try to expand it here, the sum is like 10, and we cannot do this. So we will stop here and we will see whether it is equal to x or not. But you will argue that in this case what we are doing is we are initializing L with I. We are just sending R from I to n minus 1 until the sum from L to R is like less than x, and in worst case this can also go till n square complexity. So how are we optimizing it? Okay, so to optimize this, what we can do is we will never we will never move a pointer backward. So let's say we are here and we have already expanded it till here. Instead of starting from here, that is starting L and R from here, we will move the left pointer further, that is like this, but we won't move the right pointer backwards. We will just keep the right pointer at that position, and we know that the sum of this window will always be less than x, because we know that sum of this window is less than x. So the sum of this window will always be less than x because it is the subset of this big window. Okay, so in this case what we are doing is we are only going rightwards with both L and R. Okay, so now let's try to dry run our code. First we will start both L and R with this. Now we will see that sum is 1. So, and can we add 3 into our window? Yes, and the sum will be 4, and our right pointer will point here. Now we will try to add 2. We will say that the sum would be 6, so we can add this to our window, and the right pointer would be there. Now we cannot add 5, otherwise the sum would be greater than 8. So what we can do is we can now move the left pointer rightwards. Okay, and the sum now in this case would be 3 plus 2, that is 5. Okay, now we will again try to see if we can add the 5 to our window, but we cannot add. So what we can do is again we will move the left pointer rightwards, and in this case we will see that the sum is now 2. Now we will see whether we can move the right pointer further right, and in this we can see that if we add 5 to our window, the sum would be 7. So now our right pointer is now at the 5. So left and right pointer would look something like this, and we will try to add 1 to our window. So if we add 1 to our case, the sum would be 8, that is less than or equal to 8. so we can move the right pointer here. Now what we can see is we have got the sum of window that is equal to x, and in this case we can just return the indices of L and R, that is like 0 1 2 3 4, that is like 2 comma 4. Okay, yeah, so basically what we are doing is we are going maintaining a window, and if the sum of window uh, should be like less than or equal to x, and whenever we will get the sum equal to x, then we will just return. And the complexity of this solution is like of n, because L will go to the right, the number of values L will take is like n, number of values R can take is like n, and we are never getting backwards. So so we'll be only getting 2 into n possible windows at max. So the complexity is of n. So now let's discuss another important problem for two pointer, and this is one of the most famous problems in the LeetCode, that is two sum. So in this what we are given is we are given a sorted array, and we have to find the sum of two, whether the any sum of two element is equal to x or not. Okay, and that is whether there are two such elements after arr I and arr j, and adding both of them will give us sum equal to x such that I is not equal to j. Okay, so most naive approach would be to iterate the array twice nestedly. Let's say we are going from I equal to 0 to n minus 1, and we are taking j that is equal to I plus 1 to n minus 1. We are taking all pairs of possible indices, and we are seeing whether arr I plus arr j is equal to 8 x or not. In this case x is 7, and if it is the case, then we will just return the value of indices. This process will take of n square time complexity, because we are using two loops, and each loop will have the time complexity of n, so n into n, that is n square. So in this case what we can do is we can like initialize sum with two indices, that is first and the last index, and the sum of these two will be arr I plus j. In this case it is equal to 9. Okay, so there can be two possible cases. This sum can be greater than x, less than x, or equal to x. If you get the sum equal to x, then we know we have found our answer when we can return the index. But if the sum is greater than x, then what should we do? So should we move this pointer right side, or should we move this pointer left side? If we move this pointer to the right side, we know that value of I plus 1th element would be like greater than I. So if we like subtract arr I from our answer, and we will add arr I plus 1, and we know that arr I plus 1 is greater than arr I, then we can say that we are increasing something, we are adding something more, and we are reducing something less, and so the net result will be greater. Okay, so if our answer is less than x, then we should move to the right, and if our answer is greater than x, then we should move j to the left of it. Okay, so if we move j to the left side, we know that value of the elements left side of the j is always less than it, the sum of I and j will be less than what it used to be. Okay, so in that case what we can do is we can start with this condition and we can maintain this invariant arr I plus arr j. This is I, and if it is equal to x, we can like return the answer. If it is like less than x, we know we want to increase the sum, so we will just do I plus plus, and if it is like greater than x, we can do j plus minus minus. Okay, and by doing this we will eventually reach our answer x if it is there in our array. So let's dry run this. We maintain I, j and sum. At first I is at 0th position, j is at 0 1 2 3 4 5th position, and the sum of them is like 9, and we know that x is 7. In that case sum is greater than 7, so we will move our j pointer to the left side. Okay, so now j pointer is like at the 4th index, and the sum of the two indexes is 6, and we know that this is less than our x. So in that case we will move the pointer to the right side. So even if we move I to the right side, it is still the same, so we will move it here. Okay, and now our I is at index 2 and j is at index 4, and the sum is like 7. 2 plus 5, so that is equal to 7, that is equal to x, and we can return value of I comma j, that is 2 comma 4. Now we will discuss one more problem, that is C3 sum. The problem is same, but in this case what we want is, we have been given an array and we want to find if whether the sum of 3 element, we have been given sorted array and we have to find whether sum of 3 element is equal to x or not. So the most naive approach would be go through the all the triplets and find whether the sum is, go through all the triplets and find whether the sum is equal to x or not. So j will go from I plus 1 to n minus 1, and k will go from j plus 1 to n minus 1, and if the sum of this arr j and arr k is equal to x, then we can say that we have find out our 3 sum. Okay, and the complexity of this would be like of n cube, because we are using 3 loops and the complexity of each loop is like of n. So can we do better? Obviously yes. So we want sum of 3 elements to be equal to x. So now what we can do is we can decide one element and we can find two sum problem on these two, and the value of and then we have to find basically two elements whose sum is equal to some constant. That constant is, we will just send this to the left side, and that constant would be a minus x. So like we can iterate through all the values of a, that is I will be from 1 to n minus 2, all the values of a, and we will find whether there is any combination with the sum equal to this. Okay, so our simple algorithm would be like this. We will just iterate through 1 to n minus 3 for the value of a. The value of a would be I, and we are going till n minus 3 because we want 3 element a plus b plus c, and we want to keep two indices empty for this and this, like this would be n minus 2 and n minus 1. So maximum value of 2 can be n minus 1, and the indice of b and c would be like greater than index of a, so we will go till n minus 3 only, and for that we will initialize sum is equal to x minus a, and we will find two sum in the sub array I plus 1 to n minus 1. So first we will go till here, we will try to find two sum in this sub array, then we will go till here, we will try to find two sum in this array, and so on. And in this case what we are doing is, for a we are using n value, and for each a to find two sum we are also using n values, so total complexity would be n square. So now let's look at the foursome problem. As you might have guessed, in this also we have been given a sorted array, and we have to find any four elements whose sum is equal to x. So first the naive approach would be to look at all the quadruple. Let's in the brute force manner, going from I to 0 to n minus 1, going from j y plus 1 to n minus 1, similarly for k and l, and the complexity of this method would be n raised to 4. Okay, so to optimize this, what we can do is, we can take all the pairs, all the possible pairs, like by going from I to n minus 1, going from j I plus 1 to n minus 1, and in this we will take all the pairs and we will store it in an arbitrary array 1, let's say, and it will store the sum of all the pairs. So let's say we have this as a pair and we will store 2 here, we will have this as a pair and we will have 3 here, similarly this, similarly this, similarly this 2, this 2, this 2, this 2, and all, and at last this 2, and sum of this 2 is like 13. And now the number of elements in this array 1 would be equal to number of pairs, that is n into n minus 1 by 2, so that is like n square elements, and in this n square element we can find by 2 sum whether the sum of any two pairs, sum of any two elements is equal to x or not. But one thing you should keep in mind is whether you should also write your code such that you, when finding two elements, they both should not contain similar element. So let's say you get one pair like this and one pair like this, and you want to find x is equal to like 2 plus 3 5. So when finding two sum in this array, you will get this as the answer, and you will say that I have found my answer, but this is wrong, because in this case we are counting 1 2 time, but in our question we have to find 4 different elements. So you should write your code such that it will maintain, it will handle this case as well. Okay, so this is nothing simple, you just need to also store the indices with the sum in our array. Okay, and using this we can solve this in n square time complexity. Okay, so that was it for the day. See you next week with another topic. Till then, goodbye. If you like my video, smash that like button and stay tuned, and if you want you can join our Telegram channel. The questions would be in the sheet, and till then, bye bye.